The objective of this project is to design a smart greenhouse monitoring system that automatically takes care of plants in the greenhouse using Arduino ESP32. To create coding programming code for the monitoring system and debug, test, validate, and functionally using Arduino IDE software. Third, continue monitoring and control greenhouse environment parameters using sensor and IoT platform condition in green smart monitoring to ensure it remains at the present temperature and moisture level. The step analysis is in social. The greenhouse monitoring system helped to improve productivities because people move to the cities and the population grows, and finding efficient way to product food become essential. So for the technological, the system use modern technology including sensor that check soil moisture and temperature and ESP controller to automate the greenhouse. For economic, through automation, this system helps reduce labor costs, making a greenhouse management more efficient and less time intensive. Its affordability to make it accessible for small and local farmers and supporting them in managing their crop and more efficient. So for the environmental, the system helps to protect the environment by using water more effectively and only when needed. So it also controls energy use by turning on a fan and pump only when necessary. This produce was and help create healthier environment while supporting more sustainable way and growing plants. So and last political, it also aimed at converging water energy to promote the adoption of the technology. And the last, encourage green technology and sustainable farming can increase the popularity of greenhouse monitoring system.
So, in this smart plant monitoring system circuit design, I use SYAFIQAH as a main platform to create a design circuit, which available for for a certain component such as soil moisture, THT11, 5-volt relay, battery 5 volt, and 16:2 LCD display I2C. So for other part, for customer parts such as ESP 8266 water pump and fans need to customize for their own components in the third-party software, which is a name for application is in space.
So I will present about successful result for our project demonstration. So there are 4 features for our group project. For the first one is soil moisture, which is linked to the water pump. So we put in auto mode, and the requirement is if soil moisture is greater than 20%, the water pump will be turned off, which is wet. So if the soil moisture is less than 20%, the water pump will be turned on, which is in dry. So the next is the temperature sensor, which is linked to the fan. It also in the auto mode, and its requirement is if the temperature is greater than 32 degrees Celsius, the fan will be turned on, which is hot. So if the temperature less than 32 degrees Celsius, the fan will be turned off, which is in cool. So next is the humidity sensor. It just for the monitoring environmental humidity. So lastly, we add the additional feature, which is manual override water pump. It only just for the on-off switch manual button. It also for the emergency button. So its requirement is if the water pump switch turn off, it should be turned off regardless of the soil moisture level. So if we on the switch water pump, it need to follow the auto mode requirement.
We are from Smart Agriculture Group 9. Our project title is Smart Greenhouse Monitoring System. So our component consists of the HT11 sensor that comes with humidity and temperature, and also the soil moisture sensor, one ESP8266, one fan, and also one water pump. So this is our Blink app. So we are going to use the Blink app to monitor all the system, okay, for our plant. So first of all, we have the soil moisture sensor. So as you can see, our soil moisture is 34%, which is in the water. So to activate this system, we need to insert the soil moisture sensor inside a dry soil condition. Okay, so what will happen is the water pump will pump the water from the water tank here inside this soil. Okay, so let's try it out. Okay, so as you can see, the water is pumped from the water tank inside this dry soil, and it will stop when the level of this soil moisture exceed more than 20%. Okay. So next, I would like to show you the fan, which is for the fan, how it works. So this fan will be activated when the temperature is more than 32 degrees Celsius and the humidity is less than 20%. So now I will activate the fan. So I will activate the fan. Okay. As you can see, our fan will be activated when it reaches 32 degrees Celsius. So this means our sensor is all works. So as you can see, we also got one manual water button here. So you can see this is in on mode. So when it's in off mode, that means all the sensor, even though it reaches 32 degrees Celsius, it won't be happens, or the soil less than 20%, it won't turn on the bottom also, because we want our farmer to sometimes use in this manual mode condition for some emergency or some critical conditions. So let's try if I press this. Okay, so right now it's in off mode, and right now I will pull this soil moisture up. So we expect this will be turned down, and this water pump will be not supply any water. Okay, as you can see, the soil moisture right now is less than 20%, but the water pump is not turned on. Okay, so this one is our manual mode for our farmer. Okay, so I think that's all for our groups. We hope that you can benefit from our project and make use of this in the real life. Thank you.
Let's talk about our conclusion. There are two main features in our project. Soil moisture sensor, it monitors the soil moisture level, send data to the ESP8266 to determine if watering is needed, activate the water pump when moisture falls below the threshold. DHT sensor, it measures the temperature and humidity, sends the data to the ESP8266 to control the fan, turn the fan on when the temperature is high and humidity is low to improve the airflow and slightly decrease temperature. The smart greenhouse monitoring system automates plant care to reduce the water and energy waste, ensure the optimal plant health by maintaining the suitable environmental conditions, and enhance the sustainability and efficiency in greenhouse operation. That's all from our group. Thank you.